In this section of the review, we are looking at parallel, perpendicular, and equivalent lines. You may not have explicitly talked about equivalent lines in grade 9, but they're there, they're easy. Once you know parallel lines, you'll get equivalent lines pretty quickly. So let's start with parallel lines. Parallel lines are lines that have the same slope, but different y-intercepts. This means that they run side by side. Parallel lines never get closer or further away from each other. They never touch on either end of things. So here in the diagram, I got two lines that are parallel to each other because they both have a slope of -1. The rise is -1, the run is 1. -1 over 1 simplifies down to 1. They both have the exact same slope. Thus, each point successively as we move down will go down 1 over 1, down 1 over 1, down 1 over 1, and those will run parallel to each other, never touching. You can also notice, as that makes sense, to help make it some sense, each x-coordinate is always separated by a spacing of 2 units. In this situation, it's spaced by 2 units, whichever case that you have in terms of the difference in your y-intercepts will be how far apart those lines are. Now, on top of parallel lines, we have perpendicular lines. Perpendicular lines run at 90-degree or right angles to one another. So they run at a perfect 90-degree. No other angle works there. The slopes are negative reciprocals of each other. So in a negative reciprocal, we flip the fraction and change it to a negative. Or if it's a positive, we change it to if it's a positive, we change it to a negative. If it's a negative, we change it to a positive. We flip it to the opposite side. So in the diagram, line 1 here has a slope of 3 over 2. So from this point, I go up 1, 2, 3, over 1, 2 to the next point, up 1, 2, 3, over 1, 2 to the next point. So there's our slope of 3 over 2. In the line 2, we go down 1, 2, over 1, 2, 3. So the slope is -2 over 3. So 3 over 2, if you flip that, you get 2 over 3, and you make it negative. So that's where those two lines are negative reciprocal, or slopes are negative reciprocals of each other, and thus they are perpendicular to each other. There's one more situation you might encounter, and that is when parallel lines have the same y-intercept, and these are equivalent lines. So if the slope and y-intercept are the same, you have equivalent lines. Well, obviously, sure, they're going to be the same because they have this. They have the same equation, but you might be presented with the equation in a different way. So if we take a look at an example here, I got equation 1 is y equals 4 over 5x minus 2. And I have a second equation, -4x plus 5y equals -10. Those don't look the same. There's similar numbers in there, but they're not quite the same. That has a -2, that has a 10, -10. They're different slightly. But if I take this second equation, I rearrange it, take the -4x, move it over, and make it +4 on the other side. When I add it to both sides, subtract 10, keeping the 10 there. Then I take this 5 with the y, and I divide the other side by it. As I'm dividing that other side, I'm basically taking each individual term, the 4x and the -10, dividing those out by 5. So I'm left with 4 over 5 and -2 when I simplify that down. 4 over 5x minus 2, that's exactly the same as over there. Those are the same equation. These were different original equations, but they end up representing the same line. Thus, they are equivalent. And if you were to graph these really, really quickly of a sketch that looks really terrible, you're going to have a slope or a y-intercept here at -2. You're going to go up 4 to +2 over 5, maybe somewhere over here. Both of those lines are right there. So there's line 1. I'm going to draw line 2 now. It's the same line. They are equivalent. So parallel lines never touch, same slopes, different y-intercepts. Perpendicular lines, negative reciprocal slopes. We don't care about the y-intercepts. And equivalent lines have the same slope, just like parallel lines, but also have the same y-intercept.